One, I'm going to go over this classic trig problem. This is an example where we are going to express this quantity in a simplified form. Look what's going on here. There's so many things going on here. Sine, parentheses, tangent inverse of the fraction 12/5. So what we're going to do is break this up into pieces. This inside part I am going to call theta. So look, I'm saying the tangent inverse 12/5 equals theta. Well, does that make any sense? The output of tangent inverse is an angle, or it can be at least thought of as an angle. So tangent inverse 12/5 equals theta. This means exactly tangent theta equals 12/5, but with the restriction that theta, the angle theta, is between negative pi over 2 and pi over 2. Tangent inverse 12/5 gives an angle where tangent theta, tangent of that angle, is equal to 12/5. But we're only looking for the angle between negative pi over 2 and pi over 2. So that's this inside part. That's all theta. I'm saying that's theta. And what we're going to do is find sine theta. So if tangent theta is 12/5 and theta is the angle between negative pi over 2 and pi over 2, we're going to find sine theta. Here's the method I'm using. I'm going to say theta is 12/5. I know that because it's between negative pi over 2 and pi over 2, and tangent theta is equal to a positive number, that because of that, theta has to be an acute angle. Maybe I won't go into that too much, but in quadrant 1, which is between 0 and pi over 2, the angles are all acute angles, meaning between 0 and pi over 2, it's an acute angle, and tangent's positive between 0 and pi over 2. If I were looking between negative pi over 2 and 0, tangent's negative, but this is positive. So, all right, now tangent theta is opposite over adjacent, and I'm going to make up this triangle where I've opposite is 12 and adjacent is 5. This triangle does not look like it's really satisfying that, so I will sort of just tweak it. Maybe it looks something closer to this, but still it's not, I'm not trying to make it exact, okay? Something like that. What about the other side? Some of you will know right off that we have a Pythagorean triple for right triangles. 5 squared plus 12 squared is 13 squared. Let's work it out. 5 squared plus 12 squared is c squared. I'm going to say that c is 13. People memorize this, but maybe you didn't memorize it, so I'm going to work it out. 5 squared is 25, 12 squared is 144. Add those up and you get 169. So c squared is 169. So therefore, c is the square root of 169, which is 13. But people memorize 5 squared plus 12 squared equals 13 squared. It's called a Pythagorean triple. Seems my handwriting is becoming hard to read to the point of it being impractical. 5 squared plus 12 squared is 13 squared. Got it? I think you do. Let's fix that a little bit, make that a little better here. Okay. It's still really not that good. I think maybe the pen I'm using is too thick. That's my excuse. All right. So if c is then apparently equal to 13, can we find sine theta? And by the way, this is theta in my triangle. Okay, I should have put that there. So now we're going to find sine theta, looking at the triangle. So sine theta is equal to opposite over hypotenuse. According to our triangle, Sine theta is then opposite 12 over hypotenuse 13. And that is our answer because this inside part is theta. So, in conclusion, sine tan inverse 12/5 is equal to 12/13. So that was pretty amazing. Just kidding. It's okay though. So signing off here. And all right, hopefully that works. You can always leave some comments, ask some questions. Thanks very much. Take care.